Yeah. You're freaking me out, man. I'm getting trolled by the AV crew. Don't worry, Mick. There's no need to be scared. We'll freak you out even more. We're good? Okay. So, hi. Thank you very much for hanging around here. I understand how much your brains are mashed by this point in a hacker conference, and you're probably coming off the extreme caffeine jitters, so you're in detox. So I appreciate you coming. Thanks. I'm here to talk about automating information systems, and one of the things that I've been really getting jazzed about for a little over a year now is automating incident response. Incident response probably is, you know what, not probably, it is the worst thing when it comes to information security. It's just a pain in the butt. There's no way around it. I am fortunate to work at a place that I just love. It's Diebold, a lot of fun folks. Hi, some of you that I work with, represent. It's a real interesting place, and they give me the opportunity to do some experiments. And I'm going to talk a little bit about some of the experimentation that I've been doing and where we can hopefully take information security programs. I've got no shame. This is Mohawk that I did for MohawkCon at DEF CON. I was rocking it for quite a while, but work said that that's against HR policy, so eventually it was to go. For those of you who are thinking about doing a Mohawk at some point, do it. It's a lot of fun. It's also a bit of a pain in the butt, putting all the glue and stuff in there to make it stick all the time is right. I talked about this a little bit ago. I said that doing IR is hard, and there's this weird, for lack of a better term, there's this machismo that's going on where people are like, yeah, we did that IR event, and remember how we stayed up for 36 hours straight, high five. And that just, what? That's cool that you're doing sleep deprivation experiments, but that should not be the metric that you measure your security program on. It should be about effectiveness. Unfortunately, when it comes to information security events, especially IR, we only have did you clean it up? Well, sometimes it's going to take weeks or months to fix up an IR event. And so you can't just base how hard you're working. Now, I'm not saying that it should be this. I would certainly love it to be, to the point where you're just kicking back, relaxing, and sipping on the Mai Tais. But you do need to come up with something a little bit different. Just a pro tip, a book that a couple friends of mine have recommended is Rework. Check it out if you haven't read it. It will actually flip on your head some assumptions of how to do work effectively. For instance, they'll give you all bits of advice like, don't go to meetings at all, unless they're absolutely positively forced upon you. And you will be amazed at how much work you can get done because you're not in meetings needlessly. I see some people nodding that I had a former, in a past job. Not going to name the employer, but there were people who literally from 8 a.m. to 6 p.m. were in meetings all the time and not doing the information security stuff. So that sucked. Read this book. Things got a lot interesting very quickly. So one of the concepts, though, and I'm going to try to refer to this Rework book throughout the talk, one of the concepts that's very interesting in the book is about focusing on the key things. And when we go to information security programs, we often find that people have this thing of, well, we're going to secure the things. Well, that's great. What do you mean by securing the things? Are you going to patch the OSs? Are you going to do, protect the systems? Yes, that's great. But they see that as a goal in and of itself, and that's bunk. They've missed the point. It's like when you have a pen tester who just goes and says, hey, I got shell. Whoop-de-doo. I don't care. That doesn't help. You've not shown me what the damage is to my business. What you need to do as an IR specialist is protect the stuff that the company cares about. Is it money? If it's a financial services firm, it's all about cash. Maybe it's brands. I've worked in a marketing firm in a past gig, and it was amazing. I could show them the most evil burp injection. I set up, or beef hook. I found it via burp, but I set up this beef hook, and okay, we're going to do action shots for the con. It goes on the site. What I did though was to make an interesting point with these marketing folks is we found a very nasty cross-site scripting vulnerability, and they said, you know what, big whoop. And I said, well, big whoop. Hey, I'm going to set up a beef hook, and using that beef hook, I sent down a custom exploit to them. I compromised that machine, and they said, yeah, it's an end user machine, though. It's not really that bad. And I was like, wait, what? Are you insane? So I thought about it, and I said, wait a second. This is a marketing person. So what I need to do is make it like marketing trouble for them. Well, if you have any situation, and you might want to take notes, if you ever are trying to sell a cross-site scripting or a cross-site request forgery, and that you're not getting traction from the coders or from the project managers, what you need to do is, instead of doing a JavaScript insert, you need to do HTML inject and have it say, hey, our product sucks, buy from brand X instead, you'll be redirected in 10 seconds. And let me tell you, your product will get patched with a quickness. But so sometimes brand damage is the main thing that people are concerned about. Maybe it's IP or intellectual property. We have to be focusing our IR response on what the core business is. You cannot focus your IR on just getting them out of the system and think that that's enough, because there are times that you're going to have to prioritize. It's all about making a good strategic investment on your limited time. It's unfortunate and anti-intuitive, but sometimes you need to let a low-level IR event go on while you're busy protecting the crown jewels. So you might be asking yourself, well, how are we doing on that? Are we doing a good job of protecting everything, keeping everything nice and safe? Are we? No. Yeah, you know the answer. We know we're not. So, and it's sad, but there's plenty of places to go. You look at the Verizon data breach report. Year in and year out, that thing just makes it look like we're a bunch of chuckleheads. You read the trade rags. What was the latest hot exploit or hot attack? Was the Apache one. That one really scares the bejesus out of me. They had the certs, they could sign code as Apache, and then you could push it down to people and it would be legit? Adobe, what was I saying? Apache, sorry, Adobe. Thank you for correcting me, it was Adobe. And so what's really cool is if you've ever used the tool EvilGrade, that's like amazing for that, because you would be sending Adobe signed exploits down to a client system and it would look totally legit. So EvilGrade's awesome. And you can also, one of the things that I love is going to HackerCons like this, and you hear war stories of, listen to how bad this one client is. So we know that we're doing really bad. We know that we're doing bad. And what are we doing as an industry to fix things? Not a whole lot. It's kind of weird. It's really quite sad. And when I gave this talk, this is an extension of a talk that I gave at B-Sides Cleveland a couple months ago. I gave the analogy that the information security field is on fire. It's a building on fire. And the whole suite of scripts that I'm working on is called SprinklerIr, because that's what it'll work like. It'll help put out the flame and give us time for the fire crews to arrive. And rather than rehash the fire metaphor, I'm going to talk about this. This is what we're doing. Now, I want to say I don't have all the answers. And I actually want to take a few moments to right a few wrongs. There was one thing, and I hate saying that I'm wrong, but I have to come clean. I made a big mistake in the B-Sides Cleveland one, and we'll talk about that. So at the B-Sides Cleveland event, I talked about one of the functions that Sprinkler would have, and it was a series of scripts that would help you do switch port kills. And my talk could be summarized down to this slide. And I was like, yeah, we're going to kill the port that we find bad. And a few weeks ago, I was talking with a buddy of mine, and I was walking him through like how these scripts were going to work, and we're going to release them, and it was going to be great. And he was like, well, let's walk through this. And I realized that I did a herp derp. And I'm going to explain what this herp derp is. And maybe for those of you who know Cisco stuff, you'll be like, wow, Douglas, you were like way on the path of wrong from the get-go. I'm not a Cisco guy, okay? You'll see why this was a simple mistake to make. Here's the scenario. We got a computer. It's on our network, doing computer work stuff, making widgets, whatever. It gets compromised. At this point, we have decided that this machine no longer should be on the network. It's got to go. Antivirus didn't clean it. You know, IDS isn't stopping what's going on. It's got to go. So what the initial run of Sprinkler did was it would just kill the switch port. It would log into the switch and disable the physical switch port. Hey, that's awesome. I see some people giving wry smiles. We'll get into why this is bad. So the way it would work is an IDS or an IPS type system, ArcSight or, you know, OSIM or even an administrator from their console would run this script and it would just kill the switch port. And that's great, and that works perfect. It works really well as long as you're killing a switch port that a workstation is connected to. There's uplink ports. So here's how this works. For those of you who are not familiar with it, say you've got a router in this network, like that connects to your core network. And if you start saying, okay, well, I'm seeing traffic from this IP on this switch port, we kill it. Hey, we're doing fine at this point. Where things go south is where we start killing off the uplink ports, at which point everything downstream from this has been DDoSed by us. And the scary thing is, when I was running this in my lab, after I was, informed of the error of my ways, because this is normal authorized traffic that you're blessing to go through normally, it would bypass all the IDS, IPS alerts. So I was causing DDoS conditions without even understanding why. And ultimately, in my own home network, I was able to kill my core switch fabric, which is very, very bad. So that's why I'm, coming here to say, hey, I really goofed up, and I wanted to set the record straight on that. So Scott, thankfully, said, yeah, you gotta game things up a little differently. So what we're gonna do is, one, you gotta understand the tool a little bit better. There's a buddy of mine who has this great story about, how you use a hammer greatly shows your skill as a carpenter. And I was like, well, you just, wail away with the hammer and you're good to go, right? And he was like, yeah. And I explained what was going on, and he was like, well, Mick, what you did was you flipped that hammer on its back end, and you were using the claw hammer part to break boards apart and saying, hey, I'm sawing wood. So what I've got is a working, like a very rough hackish version of the kill port utility, but it's different now. And I'm just being honest here, I came very close to doing something I try very, very hard not to do in my professional life. I've done it a couple times, but had I released this code, I'm pretty sure some people would have caused some massive outages, and so I'm kind of scared. If you really are upset about the fact that I'm not releasing the code right away, email me. I'll give you the code that I've got, but you got to pinky swear, no production use, because it's janky. But here's the smooth operator way of doing things, okay? What you do is, instead of killing the switch port itself, we're going to do MAC filtering. You might say, well, Mick, MAC filtering, that's pretty weak. They've got it on the Wi-Fi access points, and that's like lame, right? Well, no, we're not talking Bernie Mac filtering. we're talking MAC filtering. And there's a concept for those of you who aren't Cisco like really hip that it's called PACLs, Port Access Control Lists. And these are really neat things. You can think of them almost as layer 2 firewalls. And what you can do is you can filter on either an IP address or on a MAC address. And if you do MAC address filtering at the port, if we go back to this scenario where you say, hey, this MAC isn't allowed on any of these particular ports or on any of these devices, doesn't matter. All you need to do is have a whitelist of, I'll get to you in a second, all you need is a whitelist of MAC addresses that you're not allowed ever to ban, so like your core switches and fabrics, so that you don't create that DOS condition. You had a question? Okay, so the question/comment is, if you do MAC address filtering and you do that, no traffic can get to that affected host. And that instead you should do something like create a quarantine VLAN and then modify that switch port so that it moves it to there. That's an excellent point. I actually have a subscript inside the SprinklerIr framework that does that. However, that doesn't always work necessarily, depending on what is below that particular switch device. So it's a very handy tool to use. This is just another arrow in the quiver. It's the analogy that I could make to that would be, you know, when you go golfing, you have both drivers, irons, wedges, and putters. You use them as appropriate. For most desktop remediation events, that probably would be a good way to go. That's a fair point. Yeah, another question. Well, so the question is, this is network access control. Sort of. Implementing NAC, for those of you who don't know, requires you to put a certificate or some bit of code that identifies that particular hardware piece on that, you know, switch fabric, so that you have a reasonable level of assurance that that's a legitimate host on the network. Show of hands here. How many people have implemented NAC at their networks? Okay, not many. Of those of you who implemented it, did you think that it was an easy thing to do? No hand. Okay, you guys thought that it was an easy thing? Packet Fence, yes. Packet Fence is a very cool open source one. There's Cisco ICE. There are products out there that do this. Depending on your, so it's been my experience, and your experience probably varies, but it's been my experience that some networks are a little more complex than others, and that you have different levels of skill in the people implementing the project. I've been in cases where NAC has gone wrong, and that involved rolling back, and that was really tough. This is in no means meant to replace NAC. This is to give, like I said, another arrow in the quiver that would allow you to have something to bring to bear while you're getting NAC. If you had NAC, this isn't for you. I'm not going to try and sell this. Does that address your concern? Okay. Yeah, I mean, I guess the only way I could say it is for most small, medium-sized businesses, I don't think that NAC is going to be a reality anytime soon until it becomes easier to roll out. And this is something that hopefully small, medium businesses will be able to make use of with the help of a little network consultant people. Yeah. Okay, if you could send a tweet on that, that'd be very handy. Yeah, so the comment is they've got some resources and stuff, and that'd be great. again, the whole supposition of this functionality is that NAC is too high of a hurdle for many places. All right, so what I've got is with PACLs, though, they're a little bit of a pain to manage. Anybody who's managed firewall can attest that, it's kind of a pain in the butt to do the firewall rules. And imagine if each switch that you have becomes a firewall. Well, it's worse than that. With PACLs, every single port that you have has its own firewall that you need to manage. So it becomes a little bit of an administrative overhead, so I've made a series of scripts that help manage that for you. And so there's a series of PACL helpers, these Python scripts, that will check to see if PACL is enabled on a particular switch or switch port, and then it will add the MAC address to the PACL if you so wish. And then you could use these scripts to spread that access control list out to your entire network fabric, and it will also remove the PACL so that you can remove them at a later time once you've done your remediation. So any questions about that? Okay, so here we go, demo. Let's hope that the demo gods are nice. I'm sorry, what? They haven't been for everyone else? Well, so first time for everything, huh? It's kind of like the joke the pessimist says to the optimist. The pessimist says, things can't get any worse. And the optimist says, oh, yes, they can. Okay, let me, bear with me while I turn on mirroring. Okay, can everyone see that all right? Yeah, okay, cool. Okay, so the first thing that you would want to do in this type of a situation is you would want to check to see how a particular access list is for a device. And so what you would need to do is you would need to issue this command. You would need to know which switch and which port you're going to be hitting, and you can use that via Cisco Discovery Protocol, or you could use LLDP, which in my experience, you're going to have one of those two enabled. It's very, very rare that they'll both be disabled. You would enter this, or a helper script of your choosing, or ArcSight could run this. You would simply do PACL check, and then you would put the switch, and if all goes well, this will work. We'll see. I'm running GSN 3 on this machine, so it's going to take a little while. Okay, so here you see that this results spits back and it shows, hey, we've got PACL on here, so we're good to go. So now, once we know that, we can go ahead and add or modify our PACL. And that's done via the script helpfully called PACL add. And you just add whoops. So if you ever see a MAC address dead beef, you know that they're up to no good, so that's a fairly safe one to add. Pop quiz, what's the tool that adds dead beef as your MAC address? Not Sprinkler. No, there's a variety of tools that do that. A lot of the Wi-Fi hacking scripts, I'll see people like add dead beef just by default because it's it's fun. So you issue PACL add, and then it will hopefully, okay. So then it has added that MAC address to the list, and now what will happen is whenever this particular machine attempts to send traffic on that particular port, it will be filtered. So it's the effect of a layer 2 firewall. It's not going to be able to send traffic, which is great, except the issue is if they unplug from that network jack and plug into another, you're back to the races. In that case, you need to use this tool slightly differently, in which case, instead of sending it to one particular port, you would send it to all ports for that device. And you can do that. You could also use this tool to spread it out across the entire network. So that's a pretty handy function and will let you accomplish a fairly lightweight network access control type functionality for fairly low cost. In terms of, cost in terms of setting up, I should say. And then finally, so we've got the network access control list set up. We can use Packle delete, whoops. What? Yeah, you would do Packle checker. There's a Packle check that allows you to see what okay, so the question is, how would you see what Macs are already in there? The Packle check tool supports that, and you can dump the different MAC addresses that are for that particular IP. One of the things that I'm trying to get a little bit, laying all the cards on the table, one of the things that I'm having trouble making it a little elegant is to give all the Packles for all the ports on a particular switch or router device. So, yeah. Okay, great question, great question. So the question is, and I want to make sure that I have this right, is you have the host machine that you know is infected and you want it out of the pool. You have the IP address, but how do you get the MAC address for it? Oh, how do you get the switch? So the easiest way to get the IP to know which switch is handling that traffic is using Cisco Discovery Protocol. There's a function called show neighbor that you basically start querying your network fabric and saying, who has this particular IP address? Or, I'm sorry, you do it based off the MAC address. So, sorry for that. What you would do is you would go up to your core switch and say, hey, I need to know what MAC is associated with this IP. And then using Cisco Discovery Protocol, you walk through the fabric and say, which switch is the one that has this MAC address connected to its endport. So you wouldn't have to have an asset inventory. Well, okay, so the question is, are you sure using CDP and not CAM tables? You could use CAM tables. The issue with CAM tables, though, is you have to know which switch you're connecting to in order to pull the CAM table information out. And if you're in a campus environment where you might have a lot of switches, you would have to log into each switch, have it pull the CAM table, and unless there's some other way of doing that. I don't know of a way to do that without. Mm-hmm. As long as the traffic goes through that, it would work. Because you would have that mapping at the core. Sure. Yeah. Sure. Okay. Fair enough. Yes. Yes. Another case of where this would break down is if you have regional offices and you have, like, say, an MPLS cloud between them. You wouldn't be able to do that. What you would have to do is go into each office and say, do you have this particular item? Yeah, that is an excellent point. And this, will require a certain level of knowledge about how the network is laid out. You're not going to be able to just point and say, find. Yeah, okay, so NetDisco is a cool tool. The comment was NetDisco, network discovery, will periodically pull the cam tables and pull them in, and you can use that as a quick lookup against that. And that would work really well. The only downside with that is if you have somebody that's like monkeying around with the cam tables, like doing ARP cache poisoning type situations, and I'm hoping to avoid that by hitting against them directly. The other thing is I've heard of some places where, you know, like larger universities or larger organizations where just pulling all that stuff down would be a burden. Yeah. Yeah, so the comment is if you're seeing multiple Macs on a particular port, you could make a reasonable assumption that it's an uplink port and you shouldn't kill that port or like go crazy on it. Well, the only concern that I would have though is with VMware on the desktops, like you will in many instances have multiple Mac on a particular port. Now, granted, you know, depending on how your organization is, you might not have VMs on the desktop. I don't know. It's just something that I've run into, finding that there's enough times that I can't make that assumption that if it's got multiple Macs that it's, you know, safe or not. Yes? Yeah, so great question. The comment, to expand it, it says, hey, I see in the script it's logging into the script. Where are the credentials stored? Right now, it is stored in a separate config file. That's a really bad way of doing that. If anyone has a better way of storing like admin logins separately, I would love to know. A lot of people have just said, well, why don't you just log in and put your, you know, your switch port, you know, like your switch administrator password in when you run the script. I don't know many incident response teams that actually have the keys to the kingdom. That's usually network and telecom, and they don't pry their hands off that. So there's a couple slides ahead where I say, you know, hey, call to arms. I love the fact that you guys are like, well, what about this tool? What about that tool? And I love that. I need more feedback, clearly. And, you know, I've tried to think of all of them. There's plenty of rough edges, though, plenty. Okay. So, so Packle delete obviously will do exactly what you think it does. And then again, you have to specify the same switch, same switch port, and the MAC to be removed. Yeah. 10 minutes? Okay, thank you. We're getting close to the end, so okay. And then it's verified that it's removed. And then at this point, we're off to the races. Things are good to go. You're back at the normal state. Okay, so hey, things didn't totally blow up. Woohoo! All right, so call for help. I said that I need additional help. You guys did have some good ideas. I like the idea of using network disco. I have no problem with extending this and making it. I could see plenty of use cases where having that local cache just for speed sake would be great. So that would be something that I'll implement. If you've got other things, other ideas, let me know and I'll be happy to implement them. Bottom line though is, you know, I realize that this isn't a perfect solution. This has some problems, but we as an industry have been doing a really bad job of we're letting perfection be the enemy of progress. I know that this thing will break stuff. I realize that. I expect that. You know, when we first implemented firewalls, I don't know if you guys were working in the field at the time, but it was a goat rodeo. You know, And what, I want to get back to this picture, we know that there's a problem. We got the hole, but what we're doing is we're like, oh, you know what, we're going to make this safe. We're going to put caution tape around it. Well, how about we remove the slide? Or, hey, even better yet, get rid of the damn hole, fill it in, And one of the things that's interesting is, we've had a big hole in information security, and we've had it since 1972, okay? For those of you who saw my B-Sides talk, no spoilers. 1972 was an awful year for information security because what happened was that was when the first paper explaining what buffer overflows were. The first working instance of a buffer overflow was in 1972. Folks, that's 40 years. To give you a little bit of context, in the tech industry, 40 years is like caveman talk, right? 40 years ago, Nixon went to China. Elvis was skinny, still alive, and giving tours of concerts in Hawaii. 40 years ago, from a geek perspective, 40 years ago, Pong was released. We've had buffer overflows since then. We haven't fixed it. What do we do to fix the industry? I don't know. But we've got fundamental issues. We've got big holes gaping all throughout our industry. We can do things like, putting up caution tape. Or we could try to fix the hole. I hope that this talk gave you some stuff to think about. I hope that this conference that you learned a few things that challenged you, that got you fired up. We got to go to work on Monday, or at least most of us do. Let's use that enthusiasm. Let's use that energy and start fixing things. Don't let perfection be the enemy of progress. Give it a try. If things break, make sure that you do that in the lab first. So, just want to give you the little closing thought. If we keep on this present course, the alternatives, they're pretty grim. That's APT, folks. We know that we've dealt it. We've been there. I'd like to say special shout out of thanks, you guys, for coming here, especially on the tail end of the conference. Podcasters for making information security funny. DerbyCon, awesome conference. Anybody who had anything to do with it, thank you very much. Creepy Carl, keeping it creepy. All right. And so if you got any questions, comments, rants, raves, feel free to hit me up. I'd be more than happy to, take slings and arrows as well as accolades. So thank you very much for your time. Enjoy the remainder of your time here.